Have you ever gazed up at a giant airplane soaring through the sky and wondered, how is that even possible? It seems almost magical, doesn't it? The sight of a massive machine gracefully gliding through the air can leave anyone spellbound. How can something so heavy defy gravity and stay aloft? The answer lies in the principles of physics and engineering. Well, my friends, it's not magic, it's science. The intricate design and powerful engines work together to make flight possible. And the science behind it is called aerodynamics. This field of study focuses on how air interacts with solid objects like airplane wings. Aerodynamics is the study of how air moves around objects, and it's crucial for designing efficient and safe aircraft. And it's the key to understanding how airplanes conquer the skies. From takeoff to landing, every phase of flight relies on these principles. To unlock the secrets of flight, we need to understand the four forces that act upon an airplane: lift, weight, thrust, and drag. Lift is the force that pushes the airplane up, weight pulls it down, thrust propels it forward, and drag slows it down. Together, these forces create the delicate balance that allows an airplane to fly. Imagine these forces as a team engaged in a constant tug-of-war. Lift pushes the airplane upward while weight pulls it down towards the earth. Thrust propels the airplane forward and drag tries to slow it down. For an airplane to take flight and stay airborne, lift must be greater than weight, and thrust must be greater than drag. It's all about finding the perfect balance between these forces. Lift is the force that counteracts the airplane's weight, allowing it to soar into the sky. Without lift, an airplane would never be able to leave the ground. This essential force keeps the airplane from plummeting back to the ground, ensuring a smooth and stable flight. But how exactly is lift generated? The secret lies in the ingenious design of the airplane's wings, which are marvels of engineering. Airplane wings have a special curved shape called an airfoil. This shape is not arbitrary. It is meticulously designed to manipulate airflow. This shape is crucial because when air flows over the curved upper surface of the wing, it speeds up, creating a difference in airspeed above and below the wing. According to Bernoulli's principle, faster-moving air creates lower pressure. This principle is fundamental in understanding how lift is generated. At the same time, the air flowing under the wing is moving slower, creating higher pressure. This difference in pressure is key to the airplane's ability to lift off. This pressure difference creates an upward force, which we call lift. Lift is what allows airplanes to ascend and stay aloft, defying gravity and enabling the magic of flight. Section 4. Controlling the skies. Now that we know how lift gets an airplane off the ground, you might be wondering, how does the pilot control where it goes? The answer lies in the sophisticated design and engineering of the airplane's control surfaces. These surfaces are crucial for maneuvering the aircraft in the sky. Well, airplanes have special movable parts on their wings and tail called control surfaces. These include the ailerons, elevators, and rudder, each playing a vital role in the aircraft's movement and stability. The ailerons on the wings control the roll of the airplane, helping it to turn left or right. When the pilot moves the control stick, the ailerons tilt, causing one wing to rise and the other to dip, thus initiating a roll. The elevators on the tail control the pitch, moving the nose of the airplane up or down. By adjusting the elevators, the pilot can make the airplane climb or descend, which is essential during takeoff and landing. And the rudder, also on the tail, controls the yaw, allowing the airplane to swing its nose left or right. This is particularly useful for making precise adjustments during flight and for maintaining a straight path during crosswinds. Together, these control surfaces enable the pilot to navigate the skies with precision and safety. Section 5. Keep exploring. So there you have it. Airplanes stay in the air thanks to a fascinating interplay of forces and some clever engineering. The next time you see an airplane soaring overhead, remember the four forces of flight and the magic of lift. But this is just the beginning, my friends. There's so much more to learn about aviation and the science that makes it all possible. Keep exploring, keep questioning, and never stop learning.